There is one more important topic I'd like to discuss regarding binary files. Sometimes you can have program bugs reported by the users, and when you ask for more information, they give you copies of their files, which in our case is the binary data. So how could you debug the code and validate that the data in the binary file is correct? In such cases, you need to use a binary editor, and there are many binary editor programs available, and I'll show you a binary editor inside Visual Studio. And it's a good choice because Visual Studio is a free application for non-commercial use that you can download from Microsoft. So here inside Visual Studio, I'm going to click File, Open File, and then navigate to my project directory, which is named week 11. And here's my file.dat that contains all these binary strings. So I'm going to click Open, but there's a drop-down arrow like this that lets you choose Open With. And here it gives you a list of possible editor options that you can use inside Visual Studio. And our choice will be Binary Editor. So I'm just going to click Binary Editor, OK. And you see that it displays the content of the entire file. And I apologize for small font size, but I'm not going to change it because I'm using this tool in my other projects. We have here hexadecimal bytes shown on the left-hand side. And then visible text also appears inside the right-hand side panel. For debugging purposes, let's change the values that we store in this file. And for this, I'll jump to my write binary file method, and I'll just change this to something easily recognizable, such as 3 uppercase characters A, B, C. Okay, so let's save the change and run it again. So it tells us that 5 bytes were written for UTF and 6 bytes were written for the characters, and then we get the same results on the reading side. And Visual Studio Binary Editor already detected that the content has changed, so it's asking us if we want to reload. I'm going to say yes. Okay, so this is our text panel right here, and this is the hexadecimal dump of individual bytes that are stored in this binary file. So you can see that the first time UTF-8 has written 3 characters ABC with just taking 1 byte per each character, and in front of it, as we discussed earlier, we have this 2 bytes indicating the size of the UTF string written into a file, which of course is 3 characters. And the second times when we say write characters, what happens is that we just write each single Unicode character, which appear as 2 bytes per character, like this. So hexadecimal 41 is uppercase A, hexadecimal 42 is uppercase B, and finally 0043 is the hexadecimal ASCII encoding of character C. I hope you remember this technique to view your files in a binary editor and use it while developing your programs, and most importantly when you have to solve bugs related to processing any sort of binary data.